All right, this is going to be a video going over the first part of the Geometry Unit 6 review. I'm not going to be putting up the notes on the screen as I go. I'm going to be referring to them. You're going to have to kind of have your notes in front of you, the ones that go over parallelograms, special parallelograms, trapezoids, and kites. So you have those three open notes where they have the bullet points for all the properties. So I'm going to be referring to those properties, but I'm not going to be necessarily, I'm not going to be showing them on the screen. So just be aware of that as I go. So I'm just going to talk through each one and remind you of what the properties tell us about these different shapes. So starting with this first one, we've got a rectangle. And rectangles have some properties that are unique to themselves, and then they have all of the properties of parallelograms. And so that's going to be what gives us the answer to the first two problems. AD is going to be equal to BC. So BC and AD are equal to each other, and that's why this is 9. If my thing will work, let's try again here. Let's make this a little smaller. It's going to be 9 centimeters. All right, I might try to do that differently in a minute. So that's going to be 9 because it's the same as this other one. Same thing on the other side. This is 13. This is 13. CD is 13 centimeters. All right. Looking at the next one. So those are just saying, the opposite sides of a rectangle are always the same length. That's pretty straightforward. That's a property that comes from the rectangle, or the parallelogram properties, actually. The next thing is asking about dB. So dB is looking at this entire length right here in blue. But the important piece of information is actually down here. It tells us that MC is equal to 8. So that's 8. But the thing we need to know about rectangles is their diagonals are equal, and because they're a parallelogram, their diagonals are being cut in half, which means that these are the same and these are the same. And so all 4 of these lengths are 8. This is all 8. I don't know why this isn't working very well today, but that's okay. Let's try this again. So that's going to be 8, that's going to be 8, this is going to be 8, this is going to be 8, they're all going to be 8. And so that means that dB is going to be 16 because dB is 2 of those 8s put together. All right, I'm going to do some erasing because we're going to look at the next one, and that's going to be more about the angles. And actually, this is not a lot to say about this one. With the rectangle angle ADC, well, if you look at angle ADC right here, you should know, because this is a rectangle, that's automatically a 90-degree angle. And that's actually all you need to know for that one, is that the measure of that angle is 90 degrees. And so that's always going to be true for rectangles all the time. All right, so I'm going to go ahead and scroll down here for us, if I can. Let's take that off, scroll down. All right, let's look at this next one. This is going to be a trapezoid. So with the trapezoid, the first thing we know is, just like the rectangle, these sides are the same. That's going to tell me that QR is 13. So that's something you can get right away. 13 inches. Let's try that again. 13 inches. And then on the other side of that, we have this side that's 28 is the same as SR. So SR is also going to be 28 inches. All right. So that's pretty much it for that. Opposite sides are going to be the same measure. The question for PR and TQ are going to deal with the diagonals. So I'll look at each of them separately. So they want to know the length of PR. Well, we know right here that PT is 12. And if that's 12, then this is also 12, which means that the measure of the entire length is going to be 24 because it's 2 of those. It's twice as much. And so we know that we're going to get 24 inches for the diagonal PR. All right. Now on the other side, they tell us that SQ is 34. And that means that TQ is half of that amount. Half of 34 is 17, and that is the measure of that one. Pretty much That's all you need to know, is that the diagonals bisect each other. Okay, I'm going to do some erasing here from our thing. You can always pause the video for certain moments if you need time to copy down what I'm doing. But that is what we're getting there. Sorry, just make sure I erase everything here. All right, so next one. This is going to be dealing with the angles. So angles, we know that PQR is 84. That's this one. And we know that the opposite angles in a parallelogram are equal. So those two red angles are going to be equal to each other, which means that PSR, that's this angle here, is equal to PQR. And so it's also 84 degrees. That's all you got to know for that one. And then on the other side, if we want to know these angles, we know they're both the same as each other. But the most important thing we know about them is that these angles, the red and the yellow angle, they add up to 180. And so I'm going to subtract 84 from 180, and that's going to give me 96, and that is the measure of the yellow angle, 96. So that's what you need to know there. Pretty straightforward. So opposite angles are the same, and angles that are next to each other, like the ones I've circled, those are going to be supplementary, which means you subtract from 180. I'm going to do a little erasing. I'm going to erase that math so it doesn't get in the way of the next problem. Okay, so let's look at the next one. All right, on the next one, we're looking at, oops, let me undo that. Should take that off. Okay, there we go. Looking at the trapezoid now. So the trapezoid, the first thing you have to do is you have to calculate the mid-segment. The mid-segment is this line right here, and it's going to be the two other bases added up and divided by 2. So it's going to be 9 plus 15 divided by 2. And if you do that, you get 12 meters. And so that's the measure of the mid-segment. That's the first thing you need to be able to do. The other thing is really just going to be angles. It's going to feel similar to what we just did. So if angle R is 110, that's the one there in blue. The thing you need to know about trapezoids is that the angle that's across from it on the same base, so since they both touch this base here, they're going to be equal to each other. And that's how I know that angle T is also 110. And then similar to a parallelogram, the ones that are next to each other along these sides are going to add up to 180. And so that's why this one is going to be 70, because 180 minus 110 is 70, and that's what's going there. All right, so that's pretty much it for trapezoids. That's what you need to know. Let's keep going. All right, looking at kites. This first one is all about the angles. The thing you need to remember, well, first of all, I told you here that this is 103, and this is 110. What you need to know is that there's an imaginary middle line going through the figure like that. I'll draw that again a little bit better. And it cuts the figure into equal parts. So that 103 would also go here. And that's the first angle that you need to know. So you would say angle T is equal to 103. And then to find the fourth angle, the thing you need to remember is that the total of the angles of a quadrilateral is 360 degrees. And so you're going to subtract those other measures from 360. So you'll do 360 minus 110 minus 103. And what you end up with, minus 103 two times, because you're going to subtract all three of these angles. You're going to subtract all of these. And when you're done, you're going to get the fact that angle I is equal to 44 degrees. And those are your two answers there. And it's going to be exactly like that on the test. So you've got to copy one of the angles because of that symmetry, and then subtract the others from 360, and that gives you the fourth angle. All right. Next one is going to be really a Pythagorean theorem problem. So let's look at this real quick. We have, in this kite, we have MI is 15. I'll draw that right there. We have KM is 8. That's that one. And we have EM is 6. And they want us to find the measure. So you're going to use the Pythagorean theorem. The Pythagorean theorem is a squared plus b squared equals c squared. You need to go back and review that from previous units. You can definitely find the videos that I sent you for those units, and you can do it that way. But you're going to use a and b here are going to be 6 and 8 for one of these two. And then for the other one, you're going to use an a and b of 8 and 15. But in both cases, the number you're finding is the C value. So you're going to find the C value for the yellow triangle, and you're going to find the C value for the green triangle. So I'm not going to go through all of it, but I'll show the yellow triangle as an example. So you're going to do 6 squared plus 8 squared equals C squared. 6 squared is 36. 8 squared is 64. 64 plus 36 is 100. So 100 equals C squared. And then the very last thing you do to solve this is you take the square root of both sides. You can do that in your calculator, and you'll get that KE equals 10, because the square root of 100 is 10. And so that's the measure of this C right here, because that's the one I used C6 and 8 to find. And so I did the second one, but it's the same exact process for the green triangle. You use 8 and 15 as A and B, and you just do the Pythagorean theorem. So I'm not going to go over that a ton because we did that in a previous unit, so you guys all know how to do that. All right, last one on here is going to be my square. The square is going to be very straightforward. First of all, the thing we know about squares is that if one side is a length, then all the other sides are the same length, and that's why AD is 6. These 4 sides are all the same. Very straightforward on that one. That's just the definition of what a square is. And then they want to know about this angle right here, DOC. And this is coming from one of the properties of squares that comes from being a rhombus. Rhombuses, if you look back at your notes, says that the rhombus angle that the diagonals make is always a right angle. And so that's why this is 90 degrees. All right, so those are the answers for this review. The test is going to be, as usual, very similar. It's exactly the same diagrams, just different numbers and different angles, different lengths and different angles. Besides that, you guys should be good to go.